CSA, a course introduction. First off, welcome. My name is Mrs. Whalen. I earned my BS in Computer Science at the University of Virginia School of Engineering and Applied Science. I then worked from 1983 to 1994 as a programmer at IBM East Fishkill, New York, and at Manassas, Virginia. Then, from 1996 until the present, I've been a Prince William County public school teacher. From 94 to 96, I was getting my master's degree in education, while at the same time raising two very small children. I then taught at Garfield from 96 to 2000, at Forest Park from 2000 to 2016, and I have been at Colgan since it opened. The courses that I have taught include everything from Algebra 1, Pre-AP Geometry, AFDA, Algebra 2, Pre-AP Algebra 2 Trig, Computer Math, Advanced Computer Math, AP Computer Science A, AP Computer Science AB, and AP Computer Science Principles. First off, I want to welcome you to AP CSA. I'm glad you're here. This is an exciting but very demanding course. I have created Canvas units for each unit of study to help guide you throughout the year. You will find electronic copies of handouts that I give to you. I'm going to show you a list. It says below, but it's on the next screen. Links to lesson videos. Every lesson has an accompanying video that I've made so that if you are absent or if you want to go back and review it, you can. Online practice. This includes a practice test. Some of your practice will be paper pencil worksheets. Other will be answering questions and putting your answers in online worksheets or practice sets, if you will. Additionally, your assessments will be both online and paper pencil. I want you to know that in programming, details are extremely important, and this can make for some frustration and cause projects and programs to take much longer than anticipated. But that's okay. You need to have patience with yourself. After you make a few mistakes, you'll tend not to make them again, and so your work will actually speed up. Now, while assessments are to be completed individually, collaboration and peer assistance is highly encouraged when you're doing your practice worksheets, practice programming problems, things that are not being done for an individual grade. Now, the handouts that you will receive at a minimum, okay? These include but are not limited to, for each unit, a concepts checklist. This will help you to understand what you know and what you need help with. It simply lists the different objectives. You can declare and initialize an int variable, a double variable, you know the difference, etc. Things like that. So it's a checklist. Then you'll also get a notes packet that's to be used with the lesson lectures. I'm going to go over lessons, and included in the lectures are also activities and the programming snippets that you'll be doing. Right? All the lessons that we'll do in class have been recorded and will be available to you on YouTube, and the links to those YouTube videos are provided in the lessons on Canvas, so you don't have to go searching YouTube. Next, you'll get a worksheet packet that will help you understand. These worksheets will be assigned per lesson. Okay, so you get the whole set of worksheets at the beginning of a unit. So don't freak out and panic when it feels thick. Note that these are for the entire unit. These worksheets are meant to help you better understand and internalize the concepts and prepare for assessments. There will also be some online practice that you will be directed to within particular lessons. Now, with that said, in some cases, I will expect that you will have completed all the worksheets or tried all of them. Other times, there will be more practice than you need to do. I will let you know when there are things that you can skip. All worksheets have got the answers in an online format within Canvas, within the lesson that they're assigned in, so that you can check them. Finally, you should have a calendar that contains what will be done in class, the available practice, and the assessments. The calendar, just so you know, it is subject to change. Changes will be announced in class, and if there are significant enough changes to enough days, I will remake the calendar. Things that could cause a calendar to change include changes in the class schedule based on activities and things happening at school, such as pep rallies or other days that we change time available. Weather closings, delayed openings and closures, and or just finding that the class needs more time on something. Okay, when those things happen, I will make modifications to the calendar. I will not move tests and quizzes up. They could be delayed. Now, a copy of the Apcsa unit guide will also be available to you from Canvas. It's also available to you from the College Board website, and I will give you a hard copy so that you are 100% sure of everything that you have that's going to be covered on that AP exam at the end of the year, as well as what's covered in class. Now, for this course, BlueJ and JGrasp will be used as the IDE or integrated design environments. In addition to instructions provided in class for the use of these IDEs, I have tutorials and user manual links in the Unit 0 module of the course. Okay? Now, before we go further, everybody needs to mark this day, Wednesday, May 4th in the afternoon. You will be taking your AP exam in this course. It is a paper pencil exam. Okay, unless things change drastically, it will not be an online exam. You will not be taking it at home. This will be in school, paper pencil, Wednesday, May 4th. As things return more to normal, the AP College Board will return more to normal, which means there aren't lots of different days that you can take the exam on. So please set that aside. Now, when you go into Canvas and you click on your course, you should see all of these units of study. If you just scroll down a little bit, you'll see Unit 0 APCSA Introduction. That's where you can get the tutorials for JGrasp and BlueJ, things like that. As well as when we do the Karel unit that we're going to do, which isn't really a unit, it's just an introduction. Then every unit, if you click on it, it will bring up all the items in that unit. Notice that at the very top, okay, are these PDF documents that include the calendar, the concept checklist, the AP guide, and the notes packet. You will receive hard copies of these things, but should you lose those hard copies, you can access soft copies here. Then you will continue on and you can click on Lesson 1, Lesson 2, Lesson 3, etc. And down here you would see things like the quiz, the review, the test. Now, when you click on Lesson 1, what do you get? Lesson 1, Output in Java. It tells you to get a copy of the notes. Well, you've already got a copy of the notes, but notice this is yet another link to the same set of notes. Then you should attend class. And then the /watch lesson video. All of them will say attend class /watch lesson video. This is so that if you are absent from class on the day that we watch this lesson or that we do this lesson, you should watch that video. Okay? Or if after we have the lesson in class, you're like, I'm not sure what she said about this or that, or I need to review it again, you can go and watch the lesson video again. Practice. Here's a link to the worksheet. Again, this worksheet is in your worksheet packet, but should you lose the packet, you can download it here. You can then check the answers simply by clicking on the key for this worksheet. Links to online quizzes, projects, practice tests, and tests are also in Canvas. Now, retakes. Addressing the elephant in the room. First off, you are to do the best you can, your best, on the original assessment. This means regular attendance by you, completing practice work, quizzes, programming practice, and programming projects. Retakes are only possible on summative assessments. Now, while yes, retakes are to improve your grade, the more important thing, the main reason for a retake is to show that you have gained some level of mastery of this material. Specific requirements for being able to retake a summative assessment for each unit will be given for the unit. Some of the units have different types or amounts of work, and that's why I don't want to say exactly what all retakes will require. In general, however, you will need to submit a completed and corrected worksheet packet, Means you might have gotten some of them wrong, but I should see that you've gone back and corrected it. You should have completed the practice test that's provided to you online. And you should also have completed and turned in the programming project or possibly a programming set. Some of them don't have an entire project. Some of it's just a set of several programs that you're going to do. So that's what you need to show me that you've done everything prior to doing the retake. Now, retakes will be completed after school, at school. You won't be doing this on your own at home or in the middle of the night. At school, on the particular dates assigned. Retakes dates will be set and announced. I am teaching this year, and most years I will be teaching 3 different courses, so I need to give time for different retakes, and I can't do everybody in the same day. It becomes overwhelming, and there's not enough seats in the room. So the retake dates will be limited, and you will need to make it a priority to attend to complete a retake. Extenuating circumstances when you're not able to do the retake on the retake date will be handled on an individual basis. Know that if you can't do the retake on the given day for Unit 1 and Unit 2, and you come to me for Unit 3 and you still can't do it on the date, we're going to have a discussion. I'm one person, I have 150 students. You all have got to make things a priority, okay? Retake scores will not lower your scores, will not lower your overall grades. So if you do worse on a retake, it will not lower your grade. If you regularly are doing worse on retakes, again, that's going to prompt a discussion between you, me, and possibly your parent. Now, let's get started with fun stuff. We're going to look at Karel and making a robot. So we're going to have a little robot guy, and we're going to make him move around, and these little black dots are beepers. We're going to make him pick them up and put them down. So I want you to get ready to program. That's right. You're going to dive right into programming. After all, that's what you're here for, to learn how to program. So for this introductory lesson, you will be creating a robot and telling it where to move and when to pick up and put down beepers. Don't worry. We're going to go step by step, and you will receive 2 handouts in class. If you misplace either, you can access a new copy from the Unit 0 Karel page. Now, let's get started. And first, if you haven't done this already, you'll definitely need to pause the video while you go through and do this. If you go out to Unit 0 and the Karel page, you want to first, on your own computer in your Documents folder, create a file folder called Karel. Then into that folder, download all of these files, okay? These up here are the different worlds. This way you don't have to write this code. These are the different worlds. It's already been written for you. Then the different problems that you're going to be doing, yes, it's 1, 4, 5, 6, 7, 8, 9, okay? So we're skipping over 2 and 3. So we're only doing 7 problems. For each one of these programming problems, I'm providing you with starter code. So you're going to have the class and the, this is going to be documentation, and this is the Java. So what you want to do is for each one of these, you want to download the items that are available. And then finally, into that same folder, you want to download the jar file and the package file, as well as the README text. So if you haven't done that, pause the video, go out to the Canvas course, Unit 0, Karel webpage, and download these files. You're done? Fantastic. Then let's get started. First, one of the other handouts that you will receive, in addition to what the problems that you're working on should look like, you'll receive an overview. That overview tells you how to create a robot. We're not going to worry about doing the ones with the badge colors. We're just staying simple. So you're going to create a robot, and you're going to tell it which street and avenue it's on. You're going to tell it what direction it's facing and how many beepers it has to start with. Then you're going to be able to tell your robot to move, turn left, pick up a beeper, put down a beeper, and turn itself off. Notice there's no turn right, but remember, 3 lefts make a right. Now, here's what a program will look like. You will have import Karel the robot .star, import java.awt.color, and public class Karel sample implements directions. At this point in time, eventually, you will know what all of this stuff is doing. Right now, don't worry about it. You also have public static void main string args. This is a line that you should memorize, but you don't have to worry about what it's doing right now. We want to concentrate on just jumping in and doing some things first. So here's the code. This very first line, you are robot Sam. Okay, Sam is the name of the robot. You can name it Bob, Sue. You can give it your name. I could say you are robot Mrs. Whalen. Is set to new you are robot. You are robot Sam declares, says, I'm going to have a robot named Sam. Is set to new robot, you are robot, instantiates or creates the robot. And it creates it so that it's standing at 4, 6 on the grid, facing north, has one beeper, and in this case, it has a badge color of red. And again, we're not going to worry about the red colors. We're only going to do these first 4. Then you want Sam the robot to do things. So you have to address which instance, which robot, because you could have more than one robot. You could have 2 or 3 robots. So you have to say which robot it is and then what you want it to do. The parentheses are there because you could, in the future, have what we call parameters or pass it something. So in other words, if I wanted it to turn left, and I wanted to say maybe turn left 3 times, I would put a 3 in there and it would turn left 3 times. The robot that we have is kind of simple-minded, and we don't have anything that it won't take a 3. So you have to tell it turn left, turn left, turn left. But Sam.move, Sam.move, Sam.put beeper. Notice all these I'm telling Sam and then what to do. So you have to call the name of the robot, a decimal point or a dot, and then the action you want it to take. Down here you'll also see that static, you've got a world and what world it is you want, and a speed control. Again, don't worry about these. These are already written for you. We're removing some of that. Eventually we'll get to all the pieces. Right now, just want to do this. We want to get the idea of having an object, and so we declare an object, and then we tell that object to do something. So we're going to work through writing the first set of code with you. The first problem that you have to write says, start a UR robot facing east at the location shown in the picture. So notice your robot is at 7, 2. Okay. This robot's task is to pick the beeper and return to its starting location and direction and put the beeper down. This starter code that you will find is in Karel 2_1.java. So what you want to do now is go into the folder where you downloaded all the programs, and you will see little Blue Jay package. Double click. When you double click on this package, it should bring up something that looks like this. What you're going to do now is double click on Karel 2 file. So this file right here is the one that you're going to double click on. When you do that, you should see this window. Now what I want you to do after I finish explaining this is to pause the video and change Jane Doe to your name, N to your period. You can just leave author ID alone because we don't use ID numbers here. Down here where it says at author and then I received help from, if you receive help from somebody besides myself on doing this, you want to add their name. So you would say, I received help from Karel and Susan and Samantha. Okay? That just helps to track where you're getting assistance from. The rest of this stuff, leave it alone. Okay? You don't need to change it. So right now, pause the video and update the documentation. Hey, you're back. Now, what we're going to do is right in here, in this little white spot, that's where we're going to write all of our code. Everything else is done for you, so don't touch anything else, just in here. Now, if we go forward, again, right in here is where we're going to put our code to create a robot and make it perform its tasks. So everybody should have it open into this spot. What do you do first? Well, we want to start a robot facing east at the location. And again, you should name it your name. We're going to create an instance, and by the way, the double slashes is for documentation purposes. It's a comment. It doesn't affect the running of the program. So you're going to create an instance of a robot and call it Sam. So you are robot, Sam, is set to new. You are robot, 27 East 0. It's at this street, it's at 27, and I know it's weird going Y and then X, but that's just the way the code or the class was set up. It's facing east and it doesn't have any beepers. So make sure that you write this code exactly as you see it, and you must have a semicolon at the end. Now, before continuing, let's make sure you have correctly entered the code on the previous page to create an instance or instantiate a robot. So first thing you're going to do, you've got all that code there, you're going to click the compile key up here. And you're going to look down here and you should see class compiled, no syntax errors. If it says that you've got an error, go back and make sure that your capitalization and lower cases are the same, the commas are in the same place, and you've got a semicolon and the parentheses. White space does not matter other than in between here, okay? It doesn't matter if there's comma and white space. That's immaterial. But the rest of it has to be there. So do these things, make sure it compiles. Once it compiles, then you want to go back to this window and you want to right-click on your Karel 2_1, and it will bring up a little pop-up window like this. Go down, it should be the second thing, could be the first thing, okay? You want to click where it says void main string args. If you click on that, you're going to bring up this window that says Karel2_.main, and you've got a cursor here. We're not entering any data here, so you just simply click OK, and then it's going to run. And when it runs, you should see your little robot sitting right here on your grid in your world. Pause the video and make sure that you can do that. Now, as we continue on, and when I tell you to compile and run, this is what you're going to do. You're going to compile it and then run it and make sure it runs. We're going to check it as we go. So, first off, once you've got your robot and it exists here, it's facing east. I need it to face up or north. So I'm going to turn it. Now I can't just say turn left. I have to say Sam.turn left. Sam doesn't understand the word turn, okay? He understands turn left. And I have to say Sam because I could have more than one instance of a robot. So once he turns left, he needs to move up one space. So I'm going to tell him Sam.move. Once he's located up here, I need him to turn left again. So Sam.turn left. And then I want him to move twice. And this should get him positioned to this location, facing west, right above the beeper. So go ahead and pause the video, compile, and run your code. Did your robot turn and go where you wanted it? All right, I'm going to assume success at this point. So now let's move on. You want to, from this spot, turn left and then move down, pick up the beeper, and move down again. Go ahead and try to write the code to turn, move down, pick up a beeper, and move down again. Do that now, pause the video, and then come back and you can check. Did you write this code? Sam.turn left, Sam.move, Sam.pick beeper, Sam.move. Fantastic. Okay, again, compile and run it. When you compile and run, is your robot created and moving, picking up the beeper? And once it moves away, there's no black dot there anymore? If so, so far so good. Now we need to turn again, and we need to move across, move past the wall, turn, and move up so that we're back to our starting location. Try doing these steps right now. Pause the video and try it. Okay, you're back. Let's see. Sam turn left, Sam.move, Sam.move. Now he's got to turn again, turn left, and then he moves again. Compile and run it and make sure it works. Okay, finally, he has to put that beeper down, and then, oh, remember, he's facing north. When he moved up, he's now facing north. So we need him to face east, which means to turn right. But he can't turn right, so I have to turn left 3 times. So Sam.put beeper, we'll make him put the beeper down, and then he's going to turn left, turn left, turn left, so that now he is again facing east. Compile and run. Did it work? Fantastic. Guess what? Congratulations. You wrote your first program. That's what you're going to have to do. You're only focusing on creating a robot and making it move, pick up and put down beepers. Okay? So you've got 6 other programs. At this time, stop and you can start working on them. Next class, you'll have the whole class to finish up those 6 programs. Go ahead and start.